Good afternoon. Yes. Good afternoon. Yeah, I'm here to present the OPTI 6G project, giving a high-level technical overview. I am the project manager. I'm from Eurescom, and the technical manager of the project is John Cosmas from Brunel, University of Brunel, London. Yep, it's a small consortium. We have only 5 partners in the consortium. From 2 of them from France, the Université de Versailles and Eurescom, and we have Raniel from Israel, and Eurescom is the coordinator. The motivation for this activity is if one considers the market, we see that the main cost in the market is in the network access, so in the access network, and the main inhibitor is the cost of the licensed spectrum compared to the unlicensed spectrum, and ensuring the interworking of the private networks and the public networks and the non-public networks. The joint communication and sensing is a major development direction in 6G, and consequently in this activity we try to fuse the optical communication and improve the sensing and positioning offered by the 5G 6G and improving also with the optical. The main drawback is the aperture angle of the higher optical emitter, which can be dealt with later on in an higher infrared beam steering context. Now, another aspect that helped to formulate and shape our concept is the sustainability aspects, to considerably reduce the interference. We witnessed this interference, I already mentioned, between the home G node Bs or in-building networks and the 5G mobile network at large. And we want to increase the throughput by reducing the interference. At the same time, also improving the access in indoor situations, and contributing to the increase or the value of properties and buildings. Now, overall, I mean, all this reduction of interference and so on, this is in general is supporting the reduction of the transmission power and the reduction of the radiation levels. So this is a nice sustainability and environmental proposition. So to address all these motivations in this project, in the OPTI 6G, we will build on an optical wireless communication using vertical cavity surface emitting lasers and an array actually of such lasers. We will deploy and use a disaggregated RAN solution, mostly originating from Raniel, designing a cell-free network architecture using AI ML as an enabler for this WC, the optical wireless communication. And we will combine various localization solutions to improve the precision and accuracy of the localization. Yeah, I mean, one use case that one can imagine is the industrial use case, where the security and the guaranteed throughput, the low latency, the high location accuracy and high availability, reliability of the performance. This is all critical with various user devices or various devices taking part in this picture. So this is the scenario with which we imagine or target. And yeah, I mean, here is the picture of this VXL array solution. This is just a picture to give you an idea of the actual size. A broadband and cell-free optical wireless communication solution will be provided that is building on or relying on these VXL arrays, operating at the 1550 nanometer wavelength and near infrared range, providing communication services with a greater than 1 gigabit per second data rates over a distance of 5 meters, using a field of emission of 25 degrees or 3 gigabit per second, in again over a 5 meter distance with an angle of emission of 15 degrees, from from access points that are purposefully located within buildings. And the novelty of using these VXL arrays is that it prepares the way towards the beam steering solution in the near infrared waveform. As I said earlier, we are considering and using a disaggregated sub 6 gigahertz RAN solution from RANIL. It's a network in a box, which includes the NG core and the CU and DU units in one server. We will rely on and use a PHY split solution, the ORAN option 7.2, which enables the maximum virtualization. Each remote unit includes high performance active hybrid digital analog weighted beamforming antennas. Yeah, here are some figures regarding the overall throughputs. And yeah, I mean, we will at the end basically compare the resulting optical virus solution, the integrated system, with the existing system to measure our improvements. And yeah, I mean, here is a picture of the cell-free near infrared networks, and it is configured to implement the multi-connectivity, as I said, in a cell-free solution. This is improving the link quality and reliability. It has a nice feature that there is no need for extensive planning and when rolling out the system in the building, and there is no need for to subdividing the network in the non-public network in the building. Yeah, I mean, we believe that this solution will give us a good step forward in achieving an improvement of the KPI performances really into the range and where 6G wishes to go. With regard to the number of equipment that we can serve, the density, the actual accuracy of the positioning, and also the orientation, and so on and so forth. I mean, this is just a generic table, but we will measure actually all these KPIs. We have a 3 years work plan. So the first year we will have a definition and the design phase, followed in the second year with a construction phase and an integration and KPI verification, experimental testing and validation phase. Here is basically a overall network architecture or the architecture of the system, and we are considering. Yeah, this optical wireless communication and sensing source is modulated with the classical OFDMA signal, and the receivers are composed of several silicon photodiodes, The near infrared is using this VXL arrays with this 25 degree angle of emission, still definitely respecting eye safety standards and concerns. The pattern of the emission will be actually on the using both in the active unit sides and the UE sides. We will use this pattern of emission so that to support the position detection, and also angle of arrival and receive signal strength will be also considered.
Adam, your time is up.
Yeah. So here are the impacts, what we're considering, and we believe that with these impacts, we are on a good track with the 6G KPI deliveries.